Hello Year 12 and welcome to our next topic, differential equations. Now first exercise, we're going to be learning what a differential equation is and testing solutions to these. So first of all, what is a differential equation? It's an equation that includes a derivative. Now it might also include functions of x and functions of y in that equation as well. So you see this first equation has a first derivative and a simple function of x. This equation has the first and second derivative and a function of y. This has a first derivative and a function of x and y. Now we might also classify these as having an order. So a first order differential equation includes the first derivative. Second order differential equation includes the second derivative. So first order, second order, first order. Now in the same way that a function has, or even a relation, I can substitute a pair of coordinates, an x and a y in, to test if that point lies on the function or lies on the line. The solution to a differential equation is a function or relation. And if I substitute that into the derivative, into my differential equation, it will hold true. We'll see how that works. A particular solution, right, is one particular line, curve, that satisfies that differential equation. A general solution includes some sort of arbitrary constant, or more than one perhaps arbitrary constant, that solves it in a more general way. So here's an example. We want to show that this function here, y equals 2e to the x minus 1, is one of the solutions to this differential equation, to this first order differential equation. The way we do that is I'm going to substitute into this, and I'm going to need to substitute in y prime, the first derivative, and also y. Now I know what y is. Y is 2e to the x minus 1, but I need to find the first derivative of this to substitute in as well. So I differentiate that, okay? There is my proposed solution. I differentiate that and I end up with 2e to the x minus 1. Now I take my differential equation and I'm going to start by looking at the left-hand side. So the left-hand side of my differential equation is simply y prime, and we know that that's equal to 2e to the x minus 1. Right, we just found that. Now I'm going to look at the right-hand side of my differential equation. In this case, the right-hand side is x plus y, and so I'm going to substitute in there as well. I've got x, and y was 2e to the x minus 1. So I substitute those things in and simplify it. Okay, and I end up with 2e to the x minus 1 in this case. So the left-hand side equals the right-hand side. That means that the function y equals 2e to the x minus 1 is a solution, a particular solution, to y prime equals x plus y. It's not the only solution, it's a solution. Now, that's a particular solution. I can have a general solution that includes one or more arbitrary constant to describe all of the possible solutions. The number of arbitrary constants is going to be equal to the order of the differential equation. So here's another example. I'm asked to find the general solution to the differential equation y prime equals 2x. Then I'm going to find the particular solution that passes through the point 3, 2. So first of all, let's have a look at this. My differential equation is y prime equals 2x, or if you like, dy dx equals 2x. I'm going to integrate both sides with respect to x, cancel the dx's of sorts, and I've got the integral of dy equals the integral of 2x dx. The integral of dy is y, the integral of 2x dx is x squared. Now both of these should introduce a constant. But given that we don't know what the constant is, I'm just going to combine both of those together on the right hand side here. And that's my general solution. Okay, that, if you like, in this case is the indefinite integral, right, for that particular type of differential equation. So there's my general solution. Now I'm looking for the particular solution that passes through the point 3,2. So I'm going to substitute x equals 3, y equals 2 into my general solution. And that's going to allow me to evaluate c, my constant, which in this case is -7. So the particular solution is y equals x squared minus 7. But in fact, y equals x squared minus 1 or y equals x squared plus 4, all of these things will satisfy that differential equation, this differential equation. Okay, but we found the general solution and a particular solution. For the time being, we're not going to focus too much on how we find the general solution, mostly. For the time being, the focus is on finding a particular solution given the general solution. Rightio. That's the end of our first exercise, or the introduction to our first exercise. Let's just go over what we've done here. A differential equation is an equation that contains a derivative. The order of a differential equation is the highest derivative in that differential equation. Differential equations will have one general solution and many particular solutions. General solution will have the same number of arbitrary constants as the order of the differential equation, and for most of the things we're going to work on in this whole topic, that's going to be first order, so one arbitrary constant most of the time. And we can test a solution by substitution and evaluation. Okay, we look at the left-hand side and the right-hand side. Finally, a particular solution can be found if we know the general solution and a point that my particular solution passes through. I find that by substitution. Rightio, that's it for 13A. Our next exercise is on slope fields. If you've got any questions, you know what to do. Jot them down, ask me in class. See you there.